Hello and good evening to everyone. Welcome to Resultant AJ YouTube channel. I'm Vikas Sir. Welcome you all to RRB JE 2024 practice series called Game Changer, where we are going to practice thermodynamics important questions today. And as you know that in every week I take around 4 classes for mechanical at 8 p.m. So since today is Monday, so we are going to start with thermodynamics subject this week. Followed by, we'll be taking the subject of IC engine, then fluid mechanics, then thermodynamics, applied thermodynamics. So all these subjects will be covered in the upcoming classes at 8 p.m. on this YouTube channel. So good evening everyone, welcome to this session. Just reply me in the chat box whether my audio and video is fine or not. Hello Anand Prateek, good evening, welcome to a session. Good evening everyone, welcome to the session. Just please reply me in the comment box whether my audio and video is fine or not. Yes. Expecting a quick reply. Sir 15 अगस्त का ऑफर फिर से आएगा? Apratim Roy, I'm not sure, but yeah, there will be some offer definitely. I have to check that when these offer will be available to you. Okay. Hello Abhishek Kumar, namaste, good evening, welcome to a session. So 15th August offer was from 14 to 16 August, and any other offer apart from that will definitely let you know. Okay. So let's quickly start the session. Good evening once again to all of you. This is thermodynamic practice session. Hope you all have subscribed this YouTube channel. Those who have joined this session, please do not forget to subscribe this YouTube channel, and also do not forget to like and share the session as well. And there's a bell icon which you can see next to the subscribe button. This bell icon, if you just hit the bell icon, then what you will get the notification of all the videos that will be taken from this YouTube channel. You will get automatic notification. Batch lena hai sir, thanks sir. Okay, Apratim Roy, we'll see as soon as there will be some offer, we'll update you. Okay, so this is my introduction. Those who have joined me for the first time, and if you are seeing this video and you are meeting me for the first time, my name is Vikas Sir. I'm a faculty of mechanical. This is my email and this is my Telegram. I have total 7-year teaching experience, and I have total teaching experience. And I have done my MTech in thermal engineering from Thapar University. 1 lakh students, I have mentored more than lakhs of students for these examinations. These are the subjects that I have generally taught. So जी मुझे ये जानना था, मैं RRB JE फॉर्म डेट ऑफ पासिंग में जो डेट है, मुझे ये जानना था कि मैंने RRB JE फॉर्म में डेट ऑफ पासिंग में डिप्लोमा पे जो डेट थी, I am not able to understand. Date of passing is the same date you get. You have on your certificate. So if you have done completed diploma, Abhishek, the date which is mentioned on the certificate, that is fine if you have just put that date. Okay, no problem. So let's solve some questions today on thermodynamics subject, thermodynamics mechanical processes. And if you are having any query regarding any codes or anything, you can just let me know. A rigid tank contains the steam at a pressure of 60 bar. There is a rigid tank which is containing steam. The pressure of the steam is 60 bar. It has having enthalpy of 2470 kilojoule per kg. Which of the following is correct for this steam? Specific enthalpy of saturated liquid is given. Specific enthalpy of evaporation is given. You have to tell which of the following is correct. First of all, need to understand that we have a tank, and that tank is containing steam at a pressure of 60 bar, and the enthalpy, the total enthalpy of the steam is also given at this pressure 2470 kilojoule per kg. But at the same pressure of 60 bar, as you can see, the specific enthalpy is also given for liquid and specific enthalpy of evaporation. These two data, if they are available for you, that means we are talking about wet steam. That means we are talking about wet steam. and the total enthalpy of the wet steam is given this. So just apply this formula. Total enthalpy is equal to enthalpy of the liquid plus X into HFG. This is the formula. With the help of this formula, you can get the value of dryness fraction. This is called dryness fraction. This is 2470 is equal to 1210 plus X into 1575. By solving this, you will get the value of X. X is called dryness fraction. And that is one thing is sure, that this is a wet steam. This is not superheated and neither it is dry saturated, because dry saturated steam has dryness fraction equal to 1, and that is not definitely possible here. Okay, and superheated steam is not there because they have given this data. Okay, so find the dryness fraction. It will be how much? If you will solve it, you will get 0.8. So the answer is coming out to be this. Next question. For a reversible isothermal process undergone by the ideal gas, heat transfer is dash the work transfer. Since we are talking about isothermal process, for isothermal process, heat transfer is equal to work transfer. Okay, so the heat transfer is equal to the work transfer. So the right answer is option B. Clear to everyone? Option A is not the answer, cannot be related. For reversible constant temperature process, for isothermal process, temperature is constant, and if temperature is constant, then change in temperature will be 0. If change in temperature is 0, then internal energy change, which is equal to mCv dt, then internal energy change is a function of temperature for ideal gas. For ideal gas, U is a function of temperature. And because temperature difference is 0, this will be 0. Now from first law of thermodynamics, Q minus W is equal to du, which is first law of thermodynamics. By using this first law of thermodynamics, we can say that this is first law of thermodynamics. And it tells us that if this is 0, then heat transfer is equal to work transfer. Next question. What will be the specific enthalpy of the steam at 80 degrees Celsius and dryness fraction 0.9? That means at 80 degrees Celsius, dryness fraction is equal to 0.9. Specific enthalpy, now at the same this temperature, 80 degrees Celsius, specific enthalpy of saturated liquid is 335 and specific enthalpy of vaporization is HFG is equal to 2300. By using this data, can you just let me know the value of specific enthalpy of wet steam? It is HF plus X times of HFG. Same formula you will be using that we have discussed, right? 335 plus X 0.9 into 2300. Put the values, you will get the answer. Tell me what is the answer you are getting. Well, if you solve this, you will get value which is around 2405 kilojoule per kg. Okay, the similar type of question that we have discussed here. See, both the questions are same formula has been used. Only difference is that here it is asking something different and here it is asking something different. Okay, 2305, this is not correct, Gaurav. It will be 2405. Please solve it correctly. It is already 2300. So if you multiply by 0.9 add to 335, you will get 2405. The value of, hi Prisma, good evening, welcome to the session. The value of quality or dryness fraction of a substance in saturated liquid vapor mixture. In saturated liquid vapor mixture, this is a region, this is called as mixture region. This region is called saturated liquid plus vapor mixture region. You have to tell what will be the dryness fraction. Now, because you know this is called wet region, for wet region or saturated liquid vapor mixture region, the dryness fraction is either greater than equal to 0 or less than equal to 1. So we can say that it is greater than 0 and less than 1, that means between 0 and 1. And this line is saturated liquid line. This is saturated liquid line. This is saturated vapor line. On these lines, the dryness fraction is equal to 1 and here the dryness fraction is equal to 0. So this question can be asked in the exams about the dryness fraction. Next question is internal energy associated with kinetic energy of the molecules. Internal energy associated with kinetic energy of the molecule is a form of nuclear energy, chemical energy, sensible energy or latent energy. First of all, what is internal energy? Now, internal energy is also called as microscopic form of energy, right? It is microscopic energy. But we need to understand one thing. If it is microscopic energy, then it is also called energy possessed by individual molecules. Each and individual molecules have the energy that is possessed by the molecule is called as internal energy, and in that we have different form of energy. We have sensible, chemical, nuclear, right? But here it is asking associated with kinetic energy, the one which is associated with kinetic energy. All these energies are a form of internal energy. They all come under internal energy. But related to kinetic energy, now when we say kinetic energy of the molecule, then kinetic energy of the molecule is 3 by 2 kb into T. Kinetic energy of the molecule is proportional to temperature, and temperature or temperature difference or something which is related to temperature, which basically called is sensible. It is called as sensible energy. So reason why it is saying, because it is saying the internal energy associated with kinetic energy of the molecule, that will be your sensible energy. Because internal energy is of different form. Internal energy can be nuclear, chemical, sensible, latent. But related to kinetic energy will be sensible. So there are two statements which are given here. Statement A says, first law of thermodynamics is also known as conservation of momentum principle. Statement B, for all adiabatic process between two specified states of a closed system, the net work done is same regardless of the nature of the closed system and details of the process. These are the two statements and you have to tell which of the following is correct answer. There are 4 answers given here. First says statement A is incorrect but statement B is correct. First law of thermodynamics is conservation of momentum. Absolutely not. So first statement is incorrect. This is correct. Okay. Now you must be saying, sir, please check the second one. Okay. For all adiabatic process between a specified state of a closed system. For a closed system, if we are discussing about the adiabatic process between two specified states. Okay. Let's see that. Now we know that for adiabatic process, heat transfer is equal to 0. So work transfer will be equal to minus of du. Okay. Work transfer will be minus du, or it will depend on internal energy change. It only depends on the initial and final internal energy. Doesn't matter. It is, although work is a path function, but Only for adiabatic process, it depends on a quantity which is not a path function, it is a point function. Okay, that means it is, although work is a path function, but for adiabatic process it becomes a point function. So this statement is correct, that net work done will be same regardless of the nature and detail of the process, only for adiabatic process. The temperature given by perfect gas temperature scale based on temperature of a gas at constant volume is, it is in this question, it is saying that how you relate the temperature with temperature is related for a constant volume scale, constant volume temperature scale. Constant volume temperature scale means ideal gas thermometer. An ideal gas thermometer based on this is constant volume gas thermometer, constant volume gas thermometer. And what do you mean by constant volume? That is, volume is constant, then pressure will be directly proportional to temperature. So as per this we can say that the pressure of the gas, let's say the pressure at temperature is equal to 0 degree Celsius is equal to P. Okay, pressure at temperature is equal to T degree Celsius is equal to P Tp. This is called triple point. This is called triple point scale. Now at triple point scale, you can relate this. We can say that pressure is directly proportional to temperature. Okay, so according to that, you will say that the temperature of the gas divided by temperature at triple point is equal to pressure of the gas divided by pressure at triple point. This will be the relation. Temperature at the triple point, this is Tp means triple point. At triple point, temperature is equal to 0.01 degree Celsius, which is equal to 273.16 Kelvin. Just put this value here, you will get 273.16 into P by P into Tp. Okay, so the answer for this question will be option A. Okay, those who have given option A as the answer for this question is absolutely correct. Very good. Next, a body of mass 2 kg and specific heat at constant pressure is equal to 1 is available at 600 Kelvin. If the atmosphere is at 300 Kelvin and log 2 is 0.693, then maximum work obtainable from the body till it comes to equilibrium with the atmosphere. Please typing bold कीजिए सर, क्लियर नहीं दिख रहा, क्लियर नहीं दिख रहा. Is it not clear? Gautam? I don't think it's not clear. What is not clear here? Whatever I am writing, what I am writing, or whatever is written here, what is not clear? First of all, we need to find the maximum work. Maximum work obtainable. We have a body which is at 600 Kelvin. Okay, the questions should be bold. Okay, I will try to make the questions bold, no problem. Kuldeep, good evening, welcome to the session. This is 600, body is at 600 Kelvin, and the atmosphere around will have temperature of 300 Kelvin. First of all, tell me, साउंड बहुत कम आ रहा है सर, इंक्रीज कीजिए. साउंड कम आ रहा है. अब आप आफ्टर 23 minutes of session you are saying sound is less. Let me check. Is it less sound? Tell me. So tell me what will happen to this body. This body will definitely lose the heat. Body will lose heat to the atmosphere. Your body will get cooled down, right? maximum obtainable work, maximum work is equal to Q minus T naught into ds. You must be thinking, sir, what is this formula or how you have applied this formula? I have applied this formula because this is the formula we apply here. This is the formula for maximum work, which is also called available energy. Available energy is equal to Q minus T naught into ds. Okay. Because it is a body is a solid body. Okay. And for the solid, entropy change of solids and liquids can be found by using this formula. It is m into specific heat, mass into specific heat, log of T2 by T1. Although it should be T2 by T1, but since the body is losing heat, it will become T1 by T2. Here T1 is equal to 600 and T2 is equal to 300. But since the body is losing heat, there will be a minus sign, and minus sign will go inside. It will become T1 by T2. And what is Q? Q is equal to MC T2 minus T1. It should be T2 minus T1, but it will become T1 minus T2. So we can write MC 600 minus 300 minus T naught into MC log of 600 by 300. Clear? Now, if I take MC common outside, you will get what? Tell me. It will be 300 minus, what is T naught? T naught is this. T naught is this. T naught is surrounding temperature. This is 300 log 2. Clear? Mass is 2, Cp is 1. So just 2 into 1, 300 minus 300 into 0.693. Solve it and tell me the answer. Okay, if you solve it, you will get 184.2. 184.2, are you all getting this value? 184.2. Clear? Next, the equation which forms the basis of the Mollier diagram. Equation which forms the basis of Mollier diagram is, first of all, what is Mollier diagram? Mollier diagram is, it is enthalpy entropy diagram. It is a plot between enthalpy and entropy like this. Okay. And one thing about the Mollier diagram is, the slope of the Mollier diagram is, it is slope. What is the meaning of slope of a curve? It is change in the y-axis and x-axis. This is at constant pressure is equal to absolute temperature. This is called the slope of Mollier diagram. But how? What is the meaning of equation which form the basis of Mollier diagram? That means this slope, this relation, which of the following equation will give you this relation? This is the equation. TdS is equal to dH minus VdP. How? If we use this equation, TdS is equal to dH minus VdP. If I take constant pressure, for constant pressure, change in pressure equal to 0. Okay? If this will become 0, so we can say dH by ds at constant pressure is equal to T. T is absolute temperature. So the relation that which is the basis of Mollier diagram is the slope of the Mollier diagram, this, and this you get from by using this TdS equation. It is also called TdS equation. Okay. A rigid insulated tank is initially evacuated. There is a tank which is initially evacuated. The tank is connected with a supply line through which air which is assumed to be ideal gas with constant specific heat, passes at 1 megapascal 350 degrees Celsius, not 3500, 350 degrees Celsius. A valve connected with the supply line is opened and the tank is charged with air until the final pressure inside the tank is 1 megapascal, that is same as the initial pressure. You have to tell what is the final temperature inside the tank. Will it be greater than 350 degrees Celsius? It will be less than 350, equal to 350, or may be greater than, less than, or equal to 350, depending on the volume of the tank. First of all, this case having a rigid insulated tank and initially evacuated and asking the final temperature, this is a case of unsteady flow, and in the unsteady flow it is a case of charging of a tank. If you have studied this topic, when the charging of tank is there, charging of an evacuated tank, insulated tank, then the final temperature will of course gamma times of initial temperature. Initial temperature gamma is 1.4. If not given, you can take 1.4 of initial. So whatever will be the initial temperature, final temperature will be more than the initial temperature. It will be more, so it will be greater. Clear? Clear, everyone? So this equation, I think you must have studied the final equation. Charging of a tank, insulated evacuated tank, this will be the answer. For an ideal turbine, enthalpy of the gas at the entry and exit is 3000 and 2500 respectively, and having velocity of 200 and 100 at entry and exit. If the mass flow rate of the gas is 30, the approximate power output of the turbine is. How are you going to solve this question? So because the turbine is a steady state equation, works under steady state condition, we'll apply steady flow energy equation. A steady flow energy equation, if you apply, so it is, I'm writing it here, it is m h1 plus v1 square by 2000 plus g into z1 by 1000 plus q is equal to m h2 plus v2 square by 2000 plus g into z2 by 1000 plus w. My dear, here one thing you have to take care of is because in this question kinetic energy is not given, potential energy is not given, this will be neglected, and also they have not given the data about the heat transfer, this will be neglected. So if you just put the value here, this will be m h1 minus h2, okay, plus v1 square minus v2 square by 2000 is equal to power output. Just put the values which are given here. The values are, this is 30, this is 3000 minus 2500 plus 200 square minus 100 square by 2000. Solve it, you will get the answer. You will directly get power output. Tell me what is the answer you are getting as power output. Some of you are saying 15.5. 15.5. 15.5 is the answer. So it will be, the power output will come out to be 15450 kilowatt or 15.45 megawatt. 15.5 megawatt. Clear? Is it clear to all of you? These kinds of question you can expect in your RRB JE or SSC JE CBT 2. A real gas as compared to ideal gas at very high pressure occupies. Real gas compared to ideal gas at very high pressure occupies more volume, less volume, same volume, or it will show unpredictable behavior. So there is a graph which is plotted between real gas and ideal gas. Graph is somewhat like this. There is one curve which is for ideal gas lead, and this is one curve which is plotted for real gas, let's say. So let's say the yellow one is representing the real gas. Sorry, ideal gas. And this one other color, this is real gas. Now there is a curve of pressure and volume. This is a curve of pressure and volume. Tell me, at high pressure, this is a region of high pressure. At high pressure, if you draw a line, vertical line, then this will be the volume of real gas. This will be the line of, this is the volume of ideal gas. At high pressure, which will be having more volume, then volume of real gas will be more than volume of ideal gas at high pressure. Okay, real gas compared to ideal gas occupies more volume at high pressure. A real gas undergoes an isothermal process. Which of these statements are true? Real gas is undergoing isothermal process, which is constant temperature process. Which of these statements are true? So if you see, for isothermal process, we know that isothermal process means temperature is constant. And if you say, you will say temperature change will be 0, du will be 0, right? This is true for ideal gas. This whole story will be true for ideal gas. Heat transfer will be equal to work. But what about the real gas? Here they are saying real gas. For real gas, only one thing is true. Real gas internal energy is a function of temperature and volume both, not just function of temperature. So we cannot say that du will be 0. Du will not be equal to 0. And if that is the case, then heat transfer will not be equal to work transfer. But one thing which we can say that out of the options given is heat transfer will not be work transfer for a real gas under constant temperature process. Okay. For ideal gas, this should have been true. But for real gas, this is not true. So only option which is correct here is option C. Okay. Option C is the right answer. Is it clear to everyone? Which of the following statement is incorrect with reference to first law of thermodynamics? First law of thermodynamics के reference में which of the following is incorrect? Not, you don't have to tell the correct one, you have to tell the incorrect. If you see the option A, work done by a system on surrounding is a positive. When system does work on the surrounding, it is a positive value. This is a system. And outside the system is surrounding. If system does work on surrounding, it is a positive work. Work is positive. Correct. This is correct. But you have to tell the incorrect. Energy transferred to a system from its surrounding is a positive quantity. Okay, this is also correct. When we say energy transfer, See, energy transfer can be heat transfer, work transfer, both. But here to a system from surrounding. Okay, when we say energy in transfer are two types of energy that you study, that is heat and work. And these energy in transfer, heat and work, cannot be point function. That is a point function, not. It is a path function. Heat and work are path function. Okay. So this statement is not correct. They are asking about the incorrect. So that is not correct. Okay. Identify the incorrect statement, incorrect assumption made in steady flow energy equation. Steady flow energy equation you must have studied. There is an equation which we have used in the previous question, I think, to solve a question on turbine. Identify the incorrect assumptions made in steady flow energy equation. Assumptions, there are two major assumptions that we use. One assumption that we use is conservation of mass. Mass is conserved. This is one assumption. And second is conservation of energy. This is second assumption that we use for steady flow energy equation. These are the two important assumptions which we use for steady flow energy equation. But you have to tell the incorrect. There is a single interaction between system and surrounding, that is heat. This is a wrong statement, because it's not that there is just a single interaction. Okay. All right. So Pradeep, we can discuss about that. We can discuss privately. You are asking about a private job. We can discuss it privately, because here I am teaching the students to prepare for government job. So if you are having any such plan to get into private job, then we can discuss this privately. There can be many depending on where you want to work, or what are your qualifications, and what are your areas of interest. Okay. This is a single interaction between system and surrounding. No, there can be two interaction, heat and work. It is not that system surrounding can interact only by heat. There can be work interaction also. Okay. The state of the fluid at any point does not change with time. This is the assumption of steady. Steady flow में steady का मतलब ही यही है. The meaning of steady is that I was talking to Gautam. Did I say Subhadeep? I'm saying Gautam. Okay. So state of the fluid at any point does not change with time. This constant mass flows through the system. Yes, conservation of mass, conservation of energy, and steady state conditions. And all the types of interaction can take place. It's not that just heat and work. They can be enthalpy change, they can be internal energy interaction. Okay. Which of the following statement is false about constant volume gas thermometer? Constant volume gas thermometer, it traces the increase in temperature with the change in pressure. Because we are saying constant volume gas thermometer, it will be based on Gay-Lussac law. And as per the Gay-Lussac law, if the volume is constant, okay, the pressure will be directly proportional to temperature. Okay, so this is correct. This is correct. It is used in calibration of various other thermometers. Yes, that is why correct. It is why correct. Why? Because it is an ideal gas thermometer. And ideal gas thermometer are basically, they give you correct reading, because they are based on an equation, like they are based on a law. Their calibration is done, and because they are well calibrated, इनकी calibration अच्छे से है, because so that can be used for calibration of, their reading is more accurate, so that can be used for calibration. Calibration means standard to check the value. Suppose you have made a new thermometer and the value that you get from the thermometer is correct or not, that can be checked by using this thermometer, because this will give you correct reading for sure. Okay. It works on principle of Gale-Lussac, that is also correct. It is a bulb filled with a fixed amount of dilute liquid. No, does not contain liquid. This is wrong. This is false, because it contains a gas, not liquid. It contains ideal gas. Okay, so this is the wrong state. Which of the following is a required condition for heat to be transferred across a boundary? Heat to be transferred across a boundary, internal energy. As you know that heat transfer is a heat transfer. When we say transfer of the heat across a boundary, generally when we say heat transfer, we're talking about the sensible heat transfer, which depends mostly on temperature difference. There should be temperature difference for this in order to have the heat transfer. Okay, heat transfer होने के लिए you should have a difference of temperature between system and surrounding. Which of the following statement is incorrect? Internal energy has a indefinite value for every state of thermodynamic system. Internal energy of a perfect gas is a function of temperature only. Increase or decrease in stored energy of a system is numerically equal to difference of net heat and work interaction. Internal energy is property. First of all, if you see the first statement, it has an indefinite value for every state. This is only incorrect, because if we say there is a process taking place from state 1 to state 2, there is a process taking place. Okay, system has executed a process. So it is saying it has indefinite value. No, it has a definite value, because at state 1 its internal energy will be U1. At state 2 its internal energy will be U2. It's not that it will be having an indefinite, it will be have a definite value. Okay, all the other points are correct. Increase or decrease of internal energy depends on heat and work interaction. If the heat transfer is greater than work, internal energy will increase. If the heat transfer is less than work, internal energy will decrease. So increase or decrease of stored energy will depends on this difference of Q and W, right? Internal energy is a property, yes, and for a perfect gas it's a temperature function. But statement A is not correct, it is incorrect. How much sensible heat is added to water of 1 kg mass at 25 degrees Celsius to increase its temperature to its boiling point? Please read the question carefully and use your brain. Which heat they are asking? Sensible heat. Okay, and sensible heat, you know, it depends on temperature difference. So we are actually trying to heat the water from 25 degrees Celsius at 1 atmospheric pressure. At 1 atmospheric pressure, if you want to take the water to boiling point by heating it, by supplying the sensible heat. So tell me, what is the boiling point of water at 1 atmospheric pressure? It is 100. So those who know this, that the boiling point of water is 100 at atmospheric condition, then only you can answer the question. So sensible heat is mc delta T. Delta T, sensible heat depends on temperature difference. And here in this case, temperature difference is 100 minus 25. Okay, so mass is 1, specific heat of water is 4.18, and delta T is 100 minus 25. Just solve it, we'll get the answer. Yes, it will be 313.5 kilojoule. Option D. Are you getting this value, everyone? Okay, very good. Next question, which of the following statement is correct? Which of the following statement is correct? The process of passing from liquid to vapor is condensation. Liquid to vapor, this is liquid to vapor phase change is called condensation. This is a very, this is obviously not correct. Liquid to vapor is boiling or evaporation. Evaporation, or you can call it as vaporization, okay, not condensation. Okay. An isothermal line is also a constant pressure line during wet region. Wet region means in this two-phase region of any curve, if you see a two-phase region is formed, let's say these are the constant pressure line, okay. And this is temperature entropy curve. It is very obvious that from this point to this point temperature will increase. In this region temperature is constant and pressure is also constant. In this region temperature will increase. But here they are saying an isothermal line, isothermal means constant temperature line, is also a constant pressure line during wet region. Yes, this is the wet region. In wet region, the line which shows constant pressure also shows constant temperature. If you see the other options, it's not that कि हमको हमारा आंसर मिल गया, then we'll not see the other option. See the other option, what it's saying. I can see one more thing. Students are coming in the session, they are attending the session, but at least those who are coming to the session, at least you can just like the session, and you can share the session if you have some time. Okay. So that this is I have told you already, this is a new channel, and slowly students are getting to know the channel. They're joining the channel. So how the information is spread? At this point of time, best way to spread any information, any news is to share this. So this is a YouTube session, you can share it so that more and more students can come and they can join, right? Pressure, temperature are independent. Independent means they are not dependent. No, they are dependent during the phase change. Phase change means wet region. In the wet region, pressure, temperature become dependent. So if for every pressure, there is a constant temperature during the wet region. Dryness fraction is used to describe the fraction by mass of liquid in the mixture of liquid, water and water vapor. So this is not correct. This is not dryness fraction. Dryness fraction is mass of water vapor to the mixture, not mass of liquid. Okay, so this is also not correct. Mass of liquid plus mass of water vapor. So the statement is not correct. Only option B is correct. Next question. Consider the following statements. If temperature difference for heat transfer tends to become 0. Yeah, option D was not dryness fraction, it was wetness fraction. If temperature difference for heat transfer is 0, if temperature difference tends to 0 degrees Celsius, then it is reversible. Yes, then temperature is constant. In that condition, temperature change 0, temperature change is equal to 0, then temperature is constant. It is constant temperature process is reversible. Process involving friction in elastic collision should be considered irreversible. जहां पे friction वहां irreversible. Correct. Elongation of bar within elastic region. You must have studied Hooke's law. Hooke's law says that within the elastic region, if you elongate any bar, and as soon as you remove by applying the stress on it or load on it, and as soon as you remove the load, that bar will again regain that object will again regain its original shape, right? So this is elongation of bar within the elastic region should be reversible. Yes. So all these statements are correct. Yes. Dash connects the saturated liquid line and saturated vapor line. Which connects saturated liquid and vapor line? Which connects it? So saturated liquid line is this. Saturated liquid line. Saturated vapor line is this. Vapor line. And which is connecting these two lines? These two lines are connected at a point. This point is called critical point. Critical point is also the point of intersection of these two lines called saturated liquid and saturated vapor. And at critical point you find few things, that is latent heat of vaporization becomes 0. For water, the critical point temperature is 374.15 and pressure is 221.2 bar. So few important things about critical points you should know. A frictionless piston cylinder device contains a gas initially at 4 bar and 0.20 meter cube. Okay. It expands quasi-statically at constant temperature to final volume of 0.40 meter cube. Work output during the process will be solid, liquid, vapor, all three meet at triple point, and where only liquid and vapor exist, that is critical point. Correct, Kuldeep. So it is a constant temperature process. Constant temperature. So during constant temperature means isothermal process. During constant temperature process, when temperature is constant, then work is equal to P1 V1 log of V2 by V1. Pressure is, initial pressure is 4 bar. But you know this is given bar and 1 bar is equal to 100 kilopascal. You must be thinking, why are you telling me this, sir? I am telling you this because you have to get the answer in kilojoule. And the only way you can get the answer in kilojoule is by converting the pressure in kilopascal. Because only kilopascal into meter cube will give you. Pascal is Newton per meter square into meter cube. This will be kilonewton meter. This is kilojoule. The reason we need to convert this into kilopascal is this. So it will be 400 into 0.20 log of V2 is 0.40 by 0.20. Of course, you will get this value as log 2, and log 2 we have solved a question, it is 0.693. Put the value, it will get. You will get the answer. The work will be equal to, it will be 80 log 2. That is 80 into 0.693. Okay, so it will be 80 into 0.693. What will the answer? Tell me. 0.693 into 80, it will be 55.4, 55 kilojoule. Clear? Next question. Which of the following statements are true for a mechanical energy reservoir? What is a mechanical energy reservoir? You must have studied a thermal energy reservoir, like source and sink in the heat engines are called thermal energy reservoir. Here we are talking about mechanical energy reservoir. A large body enclosed by an adiabatic impermeable wall, it is a mechanical energy reservoir. It stores work as kinetic energy or potential energy, like flywheel. You must have heard about flywheel used in the engine. It stores the energy. It rotates when the initial additional energy is provided. It rotates, stores that energy, and when needed, it will supply the energy. Spring. A spring has a potential energy stored in it. Okay, and when you press the spring and release it, it provides you that stored energy. That is a mechanical energy reservoir. All the processes within a mechanical energy reservoir are quasi-static. Okay, so all these statements are correct. In a cyclic heat engine operating between a source temperature of 600 and sink temperature of 20, the least rate of heat reaction per kilowatt net output of the engine is net kilo output of the engine, least rate of heat reaction. Can you tell me which engine will give you least rate of heat rejection? Yes. Efficiency, have you heard about efficiency? 1 minus heat rejected by heat supply. If you want the heat rejection to be least, only that engine will give you the least efficiency, which is a Carnot engine. Because only the Carnot engine efficiency is maximum. And why it is maximum? Because it will be having least, it will be if the heat rejection is least, the efficiency will be maximum, and that is only for Carnot. So we have to assume it is a Carnot engine. That will why it will give you the least rate of heat rejection. And for a Carnot engine, you can say efficiency is 1 minus lower temperature by higher temperature. So it will be 1 minus lower temperature is 293 Kelvin divided by higher temperature is 873. You will get the efficiency from here. Efficiency will be equal to work output by heat supplied. Least rate of heat reaction per kilowatt net output, that is for 1 kilowatt. If work output is 1 kilowatt, what is the heat rejection? So by using this, you can get the efficiency. By put the efficiency, you will get heat supplied, and then you will get heat rejected. Heat supplied minus work. Tell me what is the answer you are getting. Tell me, everyone. Yes, don't go anywhere. This is also, I think after this we'll take just one more question. Okay, I know you guys have given so much of time and 1 hour, so just wait for a few more seconds. So efficiency will be around just 0.665 and if it will be 1.503 kilowatt, and heat rejection will be equal to 1.503 minus 1.503. That is option C. Last question for today's session. This is the last question, and it's an easy question for you guys. Last question is easy for you. Easy question. During a process with the heat and work interaction, the internal energy of a system increases by 40 and amount of heat and work interaction are. How can you solve this question? Very difficult. Two unknown. Heat is unknown and work is unknown. And only one thing is known, that du is positive and plus 40. Two unknown. दो अननोन को कैसे सॉल्व करेंगे? हाउ टू फाइंड टू अननोन? हाउ? इट्स नॉट पॉसिबल. यू शुड हैव टू इक्वेशन, बट वी नो जस्ट वन इक्वेशन टू सॉल्व दिस. दैट इज दिस. So how to solve this question? Tell me. See, few questions have to be solved by options. There you can see heat and work. So this is containing the heat part and this is work. Just put the value of all the options. If you put the value, this heat transfer, work transfer. If you put the value minus 50 minus of minus 90. If you put option A, you will get minus 50 plus 90. What you will get? You will get du is equal to plus 40. Okay, are you getting this by using the first one? Yes, by using the first option you are getting this value. So by the options you can solve this question. Okay, rest of the question will be taken in some other sessions. That's all for today, And if you have enjoyed the session, then please do not forget to, if you are new on this YouTube channel, if you have joined this YouTube channel for the first time, then please do not forget to subscribe this YouTube channel and press the bell icon. Also, if you have not liked this session, please do like it and share it with your friends who are preparing for any examination like RRB or SSC and want to study the technical, want to make their technical strong. I will see you tomorrow. Tomorrow I will see you again. And tomorrow we are going to practice IC engine questions at 8 p.m. sharp on the same YouTube channel, that is Resultant AJ YouTube channel. Thank you so much. Have a very nice day. I will see you tomorrow, all of you. Thank you so much. Have a nice day. Thank you.